In this video, we're going to continue our conversation about confidence intervals, but we are going to shift from talking about proportions to now dealing with sample means. You'll notice that the equation stays relatively the same to when we were dealing with sample proportions, with a few noticeable changes. So before, when we were dealing with sample proportions, we said that our confidence interval was simply equal to our estimate plus or minus our margin of error, which was also equal to our estimate plus or minus our z star value when we could assume a normal distribution times the standard error of the proportion of our sample, our standard error of p hat. Now what you'll see is that we have a little bit different of an equation here. So we just make this a little bit bigger on our screen. So y is equal to, y plus or minus our margin of error is our confidence interval. So this is our new equation for a confidence interval, which is also equal to y bar plus or minus t star at n minus 1 degrees of freedom times our standard error of y bar. So really, this is still our estimate plus or minus our margin of error. The only difference is that we have a bit different of a calculation as it relates to our margin of error, but still relatively the same. What we're dealing with is still some critical value times our standard error. The difference being that now we're dealing with a critical value that's a t-score and a standard error that is calculated using our sample standard deviation divided by the square root of our sample size. So we'll walk through this example in a second, but we can just remember that when we're working with a normal distribution, we remember that it's symmetrical about the mean. So this is our normal. And when we're working with a t distribution, our t distribution technically it wouldn't be higher, it would be something like this. So our t distribution the difference between the normal and the t distribution being that our t distribution has thicker tails, so there's more uncertainty in the tails of our distribution. And you'll remember the property of the t distribution that as your sample size increases, it will become closer and closer to the normal distribution. So we're using our t-score typically when we don't know the standard deviation of our population. That's usually a good hint of when we might use a t-distribution. We also might use a t-distribution when we have a relatively low or small sample size. So let's go ahead and work at a question here. So here's our question. So a large accounting firm is trying to determine what fee to charge for next year's returns. In previous years, the actual mean cost to the firm for attending a client audit session was $650. To determine if this cost has changed, the firm randomly samples 32 client audit fees. The sample mean audit was $680 with a standard deviation of $75. And in this question, what we're asked to do is we're asked to develop a 95% confidence interval estimate for the mean audit cost. Okay. So why don't we do a few things here? So let's write down what the question gives us. So the question tells us that x bar is equal to $680, right? That's the mean of our sample. That's told to us right here. And we're told that the standard deviation, so the SDX, is equal to $75. We'll just put this in dollars. And we're told that we have a sample size of 32, right? That's told to us. right here. So we can then go ahead and create our confidence interval. So we'll recall that the equation for our confidence interval is the following. Y bar plus or minus our T star at n minus 1 degrees of freedom times our standard error of Y bar. Okay, so first, why don't we go ahead and just separately calculate our standard error, or, well, we can just do this. So we said that Y bar, in this case, we said that this was X bar. So let's just change all this so that it's consistent. There we go. So we said that Y bar was equal to 680 plus or minus our T star at 32 minus 1 degrees of freedom times our standard error of Y bar. And of course, our standard error is equal to our sample standard deviation. So 75 divided by the square root of our sample size, which is 32, right? SE Y bar is equal to the sample standard deviation divided by the square root of n. Okay? We can say SD Y bar. Why not? Typically, little s is reserved for standard deviation of your sample. So we have 680 plus or minus our T star at 31 degrees of freedom times 75 divided by the square root of 32, which gives us 13.258, and we'll round to 4 decimal points, so 83. So now all we have to do is we have to calculate what is, or we have to establish what is our T critical value. So what we're going to do is we're going to go to our T table, and we're going to identify where our 95% is. So our 95% confidence level, and sometimes T tables give you this nice kind of cheat sheet at the bottom where it says 95%. So we're going upwards in this column. But if it doesn't have this for you, and instead it gives you the tail probabilities, well, we recall that if we have a normally distributed, if we're having our T table and we're looking for our 95% confidence interval, that means that we have 0.025 in each tail, right? Similar to exactly what we would do with the normal distribution. So now what we're going to do is we're going to go and we're going to look at where that is on our T table. That is, of course, right here. And we can see the cumulative probability in 2 tails is equal to 0.05, or the cumulative probability in 1 tail is equal to 0.025. That's exactly what we said we were looking for. And now what we're going to do is we're going to then say, okay, so we're in this column, and conveniently we're in the right column. It says this right here at the bottom for us. We are going to look up 31 degrees of freedom. So this is our degrees of freedom right here on the right. So we're going to trace our finger down, and we look and we see that there is 30 degrees of freedom and 40 degrees of freedom. We are going to round down to 30 degrees of freedom, and this will be our critical value, or our estimate for our critical value, 2.042. Now, there is a more precise way to calculate this T critical value without computation. Of course, if you have the luxury of computation, you can find this value exactly. But you can also use a method called interpolation to estimate your t-critical. We will cover that in another video. So for now, let's just use 2.042 as our estimate for our t-critical. So we have 680 plus or minus 2.042 times 13.2583. So 2.042 times 13.2583 gives us 680 plus or minus 27.07. So this is effectively our margin of error. So from there, we can just calculate our confidence interval. So we get 680 minus 27.07, which gives us 652.93. And we get 680 plus 27.07, which gives us 707.07. Of course, these are in dollars, so we could be more specific in our confidence interval. So 652.93 and 707.07. And there we have it. We've just established our 95% confidence interval estimate for the mean audit cost. That's it for this video, but if you found that it helped make statistics easy, consider showing your support by giving the video a like. And if you still need more help with statistics, then consider subscribing to the channel if you haven't already. I look forward to solving many more problems with you next time.